Underwater vibration monitoring can be accomplished through various methods and sensor styles. The first and most commonly deployed option for straightforward underwater applications are general-purpose vibration sensors combined with a waterproof cable assembly.
These two models, and most standard industrial vibration sensors in general, are specified as being hermetically sealed. Generally, this hermetic rating means that the sensor can be paired with an appropriate cable assembly to achieve an IP67 or IP68 seal and enable use in relatively shallow depths. IP67 solutions are qualified to operate in up to 1 meter of fluid and are often selected for outdoor applications or those where the sensor will be exposed to splashing or washdowns. IP68 solutions are qualified for indefinite submersion at depths greater than 1 meter, though the ultimate rating depends on the connector itself. The R6Q connector from Wilcoxon, for example, is an IP68 Viton boot style 2-socket mil-C-5015 connector that has been tested up to 650 psi, the same pressure as most true underwater sensors. This can be paired with a general-purpose accelerometer and used for most generic underwater applications, as well as those where chemicals, oil, or other aggressive fluids are expected to be encountered. The next step up from using a general-purpose sensor paired with a separate, appropriately rated cable assembly is the use of an integral cable sensor. This design removes the connector entirely, be it a 2-pin mil or a 4-pin M12, and replaces it with a direct cabled output. Eliminating the need for a separate cable assembly removes a potential point of failure at the cable connection interface and enables the cable to be bent closer to the sensor body, a benefit in compact applications where space is at a premium. These sensors are generally only rated to depths of about 10 meters or 32 feet, which is sufficient for most general-purpose applications, and are a good alternative for those who distrust using a two-piece solution when submerged. Alternately, any damage caused to the cable would require the entire sensor cable assembly to be replaced, which can be tedious and costly, depending on the application and machine location. One improvement on integral cable sensors incorporates overmolding, a process of fully sealing the sensing element from outside contaminants while simultaneously forming the sensor housing. Finally, the premium option for underwater sensors is just that, a true, top-of-the-line accelerometer that is rated for underwater use. These sensors follow typical IEPE sensor construction methods, but improve upon the material selection. A titanium case should be used for strong performance at high pressures, lighter weight, greater corrosion resistance, and the ability to better withstand extreme temperatures. The sensor will likely use an integral cable design that is potted, or encapsulated by a gelatinous material, eliminating the potential for water or other liquids to find their way inside the sensor and disrupt the circuitry. A top-tier helium leak test will be performed to ensure no contaminants can enter the sensor body, and pressure testing will be done to verify the build. These underwater sensors are understandably priced higher than the two solutions previously discussed, general purpose and integral cable sensors, but when critical machinery or high pressures are involved, the price tag is worth the clear